In machine learning, there's a rule of thumb that is often used with smaller datasets. The rule states that you need at least 10 times as many rows as your dataset has features. So if your dataset has 20 columns, so features, you should have at least 200 rows for optimal results. However, it is essential to use statistical methods to estimate sample size with larger datasets. These methods allow engineers using AI to calculate the number of samples required to ensure sufficient accuracy and, very important, reliability in your models. Welcome back to a new AI and engineering video, a series where we walk through strategies, explore algorithms, and discuss trends in the world of AI and how engineers like yourself can benefit from them. Today, as you can already tell from the title, we're answering a fundamental question in machine learning that often perplexes engineers. How much test data do I need? This question lies at the heart of every machine learning project and really can make or break the success of your project. In the fast-paced world of engineering, traditional testing approaches often pose challenges. For example, the test matrix may become too large to be practically validated in a physical test plan. Engineers find themselves in a dilemma to discover the optimal combination of test parameters to validate new designs against key performance requirements. From working on over 300 AI projects, we know that you or your team of engineers often face a troublesome dilemma. Test too much and you waste time confirming what you already know and needlessly delay a new product's launch date. Test too little and risk missing performance or safety issues which can cost tens of millions and even billions in product delays and recalls. Now let's talk about the elephant in the room: data. The longer you are in the business, the more design iterations you probably have done, resulting in a substantial amount of data. This wealth of engineering data is often underutilized, very noisy, and often not even in the right format, or maybe even unstructured and you need it in a structured format. Our recommendation: properly pre-process and work with algorithms particularly tuned to engineering applications to learn from your existing data, with which you can then build robust machine learning models and optimize your engineering processes and accelerate time to market. Customers designing and testing numerous products can automate the design process for new products using AI, entering customer requirements into a software utility powered by AI algorithms. Now, what if you have medium data available? So if you, for example, have, let's say, a moderate amount of data, let's say a few hundred points, for example, there's not really magic or a magical threshold guaranteeing a model with good accuracy. The impact will really depend on factors like the nonlinearity of the problem and the number of dimensions you have. Organizations with already like 2 to, let's say, 500 tests, depending on which application we're talking about, can build recommender systems and run targeted optimization codes, delivering useful insights and optimizing products faster. Now imagine if you have a small amount of data, so less than maybe 200 tests or significantly less than 200 tests. Perhaps due to cost constraints or maybe even limited access to test facilities, what we see very commonly happening in the industry. AI models can at this level still be valuable or maybe a valuable extension of your engineering expertise. You can detect correlations, investigate failure scenarios, and build AI models to recommend what to test next. The Next Test Recommender, short NTR, a new capability available on Monolith, applies a proprietary active learning technology to help you find the best combination of test parameters to address key design considerations. Using a relatively small number of tests, you can already build an initial AI model in Monolith and then iterate through more tests based on guidance from this NTR. With each iteration, you then retrain and improve the model to address unknowns in the design space. And as you iterate, you are constantly re-evaluating the results and finding the next set of parameters to test to cover your design considerations. Using this iterative active learning approach, you can validate your designs with much fewer test steps and still achieve the same or even better level of coverage and confidence. What if you have no data available? The good news is, ladies and gentlemen, that you will eventually produce data by performing tests. So if you properly plan your data creation or maybe even acquisition strategy, what we call it, you can get to a point where you have enough data to use the Next Test Recommender and avoid the over-testing issue. The key to successful machine learning really lies in organized data management. You must build, or maybe even buy a solution, whatever you prefer, to make data pre-processing, model training, result exploration, and maybe even sharing these results seamlessly and as easy as possible, maybe for your team, for yourself, or even the entire organization. One challenge engineering organizations face is generating accurate predictions during a given design cycle. This is where AI can improve the accuracy of early-stage predictions. Simultaneously, there's a much higher chance of a faulty design in the earliest stage of the process. Therefore, the data available to engineers at this stage is really vital. For those with extensive historical data, leveraging machine learning can lead to significant advancements in design optimization and automation. Even with a relatively small dataset, AI models can offer valuable insights and help you, the engineers, make informed decisions and even choices. The key to an effective machine learning strategy lies really in understanding your specific context, whether you have big data, medium data, little data, or no data. And it's not about the amount alone, but also about the quality of the data. At Monolith, we've got a team of experts who can work with you and your team to not only reason about the scale of data that may be required to capture the useful complexity in the problem reasonably, or if you don't have data yet, we can help you basically adopt an AI strategy and tell you basically how you can acquire your first data points to make sure you don't overtest, you don't undertest, and will help you actually adopt AI and get you into our platform using the next test recommender. In the description, you will find every relevant link that is helpful for you to understand what active learning is all about, maybe a blog post of how much data you actually need, kind of a summary of what we've discussed in this video, and more relevant information such as webinars, white papers, and so on and so forth. Hope this was useful to you. I'll catch you in one of the next AI and engineering videos. Bye bye.